সে তো আছে দেখাচ্ছে কখন হলো তাহলে হলো এসছে আচ্ছা তো আচ্ছা আচ্ছা কিচ্ছু হবে না
नमस्कार सर।
हाँ नमस्कार।
मैं विचार पूर्ण कंप्लीट केलं
So, good afternoon to all of you. Good afternoon, sir and madam. So, it is not clear for me how many we are present. Professor Onesha Mukherjee, are you present?
Yes, sir.
Professor Dilip Patil. Professor Dilip Patil. Please unmute Professor Dilip Patil. Professor Bishwajit Sinha. Okay.
Good afternoon, sir.
Good afternoon, sir. Dr. Shivashankar Nayak. Professor Nayak. Okay. Professor Dr. Anup Kumar Sain.
Yes, sir.
Okay, thank you so much.
Sir.
Professor Harshavardhan Reddy. Professor Harshavardhan Reddy. Professor Jagadeshwari. Professor Jagadeshwari. Professor Bipin B. Tripathi. Professor Tripathi, please unmute. Professor A.R. Anand Pandey. Professor A.R. Anand Pandey. Professor Shubhalakshmi. Professor Kirti.
Present, sir.
Thank
Present.
Thank you so much. Professor Mathan Kumar. Professor Mathan Kumar. Professor Meenakshi Majumdar.
Yes, sir. Good afternoon, sir.
Good afternoon, madam. Professor Nirvan Vishwas.
Yes, sir. Good afternoon, sir.
Thank you so much. Good afternoon, sir. Professor Safarraj Alam. Professor Safarraj.
Present, sir. Good afternoon, sir.
Good afternoon, sir. Thank you so much. Professor Meenakshi Majumdar.
Yes, sir.
Thank you. Thank you. Professor Parul.
Yes, sir. Yes, sir.
Thank you so
Hello.
much. Yes, yes, madam. Professor Rashmi.
Yes, sir.
Yes, thank you so much. Professor Shasmita Sahu. Professor Shasmita Sahu. Professor Rupesh. Professor Rupesh. Professor Somit Das. Professor Somit Das. Professor Sangeeta Agarwal.
Yes, sir. Good afternoon, sir.
Good afternoon, madam.
Sir, how are you?
Fine, fine. I'm not so much fine because I am calling nobody. Professor Sharup Bose.
Sir, I am Sumit Das.
Sir, good afternoon, sir. Good afternoon, sir.
Yes, sir. Good afternoon.
Sir, good afternoon, sir. I am Sumit Das.
Good afternoon. Good afternoon, sir. Victor Chakraborty, Professor Chakraborty.
Yeah, present, sir.
Thank you so much.
Present, sir.
Professor Rishi Mittal. Professor Rishi Mittal. Professor Bhinita.
Yes, sir.
Thank you so much, madam.
Good afternoon,
Good
sir.
afternoon. Good afternoon, madam. Professor Amit Kumar De.
Good afternoon, sir.
Good afternoon, sir. Good afternoon. Professor Shiva Shankar Nayak. Yes.
Good afternoon, sir.
Yes. Good afternoon, sir. Professor Indranath Mondal. Professor Mondal.
Yes, sir.
Thank you so much. Good afternoon, sir. Okay. So maybe we out of this 52, maybe 30% we are present. So no issue. It is not an issue.
Sir, I am present. Shantanu Patro, sir.
Santanu Patro, yes.
Hello, sir. Very good afternoon. I am Shubhangi Vasake. I am also here, sir.
Okay.
Sir, good afternoon, sir. My name is Praveen Kumar. I am present, sir.
Yes.
Hello.
Sir, good afternoon, sir. I'm Dr. Kranti Zakade. I'm also present, sir.
Thank you so
Good
much.
afternoon,
madam.
sir. My name is
Good
Anand.
afternoon,
Hello.
sir.
Good afternoon, sir.
Hello.
Hello,
Okay,
sir.
okay. Okay, thank you so much. Thank you so much.
Yeah,
So,
hello, sir. I'm also present, no, sir.
okay.
Oh, with me, sir.
Thank you, sir.
Majority must be granted. Majority must be granted. Okay, so I'm requesting to all of you, please once again mute your audio. Please mute your audio. Okay. Officer Jagadeshwari, please mute your audio.
Sorry.
Yes. Okay, so thank you so much. So welcome to this session. This session is very much important. I feel that's why I'm calling one by one. Not one by one, it is not possible. It will take not more than 50 minutes. Okay. Now we have to start our today's laboratory session. I think in engineering education, this laboratory session is very much important for us. Hello. Okay, so today's our planning is like this. Before starting this demonstration session, I feel this one is very much important for us. Still now it's depend on your patience as well as your patients. So 2P are very, very important for this session. One is patients, second one is your patient. Okay, so you have to follow all this experiment. So total experiment, what we are planning, like say, if we start from very analytical parameter, all of you know some of the analytical parameter, like say turbidity, pH, conductivity, TDS, fluoride concentration, copper concentration, so many things. But today we are going to start the laboratory, that laboratory basically for analysis of the effluent, rather called liquid waste. And after this 2.5 days discussion, it is very much clear for us. So this analysis part is very, very important before management, rather called treatment. So this experiment, or rather called analysis, depend on some parameter. But today we are going to start our laboratory, that is basically the analysis of our liquid effluent, or rather called wastewater. Simply we may say wastewater analysis. But some of the common parameter, all of you know, some of the common parameter, if we consider our drinking water as well as wastewater, some common parameter are there. Like say pH is the common parameter. Okay, like say fluoride ion concentration, this is also common parameter. But some exclusive parameter for our effluent analysis, rather called wastewater, all of you know, after the discussion of our industrial people, that is Dr. Ashim Kumar Bhattacharya, he already explained, yes, TSS, this is very, very important. But this TSS, full form is the total suspended solid. But in wastewater industry, they are using another form of TSS. That TSS is called actually MLSS, mixed liquor suspended solid, MLSS. Okay, so today we shall try to measure TSS, but don't forget it. This another name, whenever we are entering the wastewater engineering laboratory, this TSS, another jargon people are using, that is called MLSS, mixed liquor suspended solid. So we will come to this point, but our total planning is very big. And it's depend on again 2P, your patients and your patient. Both are very much important. Okay, so we shall try to show some normal parameter. You are thinking some abnormal parameter are there. Yes, I shall introduce so-called some exclusive parameter. Don't say abnormal parameter. Exclusive parameter for wastewater. But we have to start from pH, then turbidity, then conductivity. These are simple parameters. But in hazardous waste management class, our guest teacher already explained, in hazardous waste, if it is in liquid in nature, sometimes we may say this hazardous waste, why it is called hazardous waste? Because corrosiveness is very high. Corrosiveness means either may be highly acidic or may be highly basic or alkaline. That's why we already chosen pH is very much important parameter of wastewater. Another one is the turbidity. Turbidity is nothing but a haziness parameter. Yes, we shall try to show this one. Okay, during turbidity experiment, we will discuss. Then conductivity and TDS, both are very much important for water as well as wastewater. Another one is the very simple parameter like total hardness. Yes, if time permit, obviously we shall show you. But some exclusive parameter for our wastewater, basically the BOD, COD and DO. And DO is the part of BOD. So we shall show you Another one is the nitrate nitrogen, because in wastewater engineering, you already receive some nitrogenous parameter, like say some people say nitrate nitrogen, some people say ammonia nitrogen, first NH3 then hyphen nitrogen, some people say Geldal nitrogen. Okay, so there are several types of nitrogen we are using in our wastewater engineering, but Geldal nitrogen means basically we are considering organic nitrogen. Okay, but total nitrogen, when we are considering in case of wastewater engineering, we have to consider Geldal nitrogen, nitrate nitrogen, ammoniacal nitrogen. Okay, that is called total nitrogen. That is very, very important for wastewater engineering. So out of this, we shall try to show nitrate nitrogen, because nitrogen is present along with oxygen. That is called nitrate nitrogen. We shall try to show another one is the fluoride, and fluoride is very, very important parameter. During our experiment, we shall discuss some heavy element like copper. Whenever this copper is present in our wastewater, if it is more than the standard, that is very much detrimental for our health. Okay, because this wastewater, untreated wastewater, sometimes it is mixed with our drinking water source, either in the surface water or maybe our underground water. Forget about that. No theoretical discussion, only practical. Now, we have to start just now our practical, but don't forget it. We shall try to show some exclusive parameter like TSS, like BOD, like COD. But problem is this. First of all, this program is only 1 week. Second one is the time-bound practical, some time-bound practical like COD. If we want to complete this one, at least 2 hours is required for digestion. And all of you know, for BOD practical, at least we need 5 days. Okay, but nowadays people are using the BOD for 3 days. That is the minimum time duration. At that time, for 5 days, we are considering the temperature is 20 degrees centigrade. But for 3 days, sometimes we are measuring BOD, but the temperature is 27 degrees centigrade. And our technocrat, our scientists, they already established BOD at 20 degrees centigrade for 5 days is more or less equal to BOD at 27 degrees centigrade for 3 days. The value more or less equal. So most of the industry now they are using for measuring this BOD at 27 degrees centigrade for 3 days. Forget about that. So now we have to start our practical, our first practical. So if you face any problem, please unmute it and you can say your query. Okay, if you are patient, that is very much important. Patient and patience. Mr. Siodia, please join with us.
Namaskar, sir.
Namaskar. So without wasting time, so just to listen my voice. So I'm requesting to all of my professors, those who are present only. Mr. PD Siodia is visible or not? It's written over here below its picture, Pobin Chandra D. Siodia.
Yes, sir.
Yes, sir.
Okay.
He is visible.
Is visible. So sometimes you can use some help from computer science department. Okay, like one process you can use. Just Mr. Siodia is showing his picture. So if you are using computer, the right hand side, two things are there. One is mute, another is three dotted line, 3 dot. dot 1, dot 2, and dot 3. 3 dot. You can click this 3 dot, okay, and you can get mute, stop video, chat. That below that one word is there, that is pin. You can click the simply pin. Then this picture automatically enlarge. Okay, please follow this one. So now Mr. Siodia is visible or not?
No, sir, not to me.
Yes, sir.
Yes, sir,
No,
visible.
sir.
No, sir.
You can see Sisuya, sir.
Yes, sir.
So don't follow my picture. You can get Mr. Siodia, say something. Say something.
Namaskar, respected participant. Myself
Yes.
is PD Siodia. My full name is
Good afternoon,
Praveen
sir.
Chandra Dayalji Siodia. I
Okay,
am
yes,
a
sir.
Good
seated
afternoon, sir.
technical assistant of Environment Pollution and Monitoring Laboratory, NITTR Kolkata.
So now he is visible.
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes,
So
very
please follow Mr. PD Siodia's camera and listen my voice. Okay, only listen my voice only. Okay, don't follow SN Mondol or NITTR Kolkata host, me like this. Don't follow it. Only listen my audio. So we are going to start, Siodia.
Yes, sir.
तुम्हारा बैक कैमरा ऑन करो.
Yes, sir.
बैक कैमरा ऑन करो.
Yeah, now it is on.
So बैक कैमरा तुम मुरारी का पास दे दो.
Yes, sir.
Okay, so first our practical not here. Turbidity. Turbidity is our first practical.
Yes, sir. Please come.
Okay. So please on this instrument. Okay, see. First, let me explain fast. I shall explain not more than 1 minute. This is the very simple instrument. It is present and people already purchase in their water and wastewater engineering laboratory, rather called environmental engineering laboratory. Because turbidity is very, very important, not only our drinking water, but also the wastewater. I think it is clear. And this turbidity meter, basically today we are going to use that make. Sometimes you can write in your notebook, make is hack company, not hatch, HACH. Pronunciation like hack company USA. Okay. So here model number, it is showing 2100P turbidity meter. And this turbidity meter, type of this turbidity meter is called nephelometric turbidity meter. Okay, there are so many other old turbidity meter like Jackson turbidity meter, but this one is the latest turbidity meter. Okay, so we are going to measure the turbidity. Turbidity is nothing but a haziness parameter. All of you know. More haziness means more pollution. If your wastewater turbidity is very high, means it is polluted. In case of drinking water, I may say turbidity of our drinking water, as per our national standard, it should not be more than 1. And unit is, don't forget it, unit is NTU. It is showing, just to see, unit it is also showing 0.00 NTU. NTU full form is the nephelometric turbidity unit. You all of you, I think, know nephelometric turbidity unit. Some people are thinking, why nephelo? Nephelo is the Danish word. In English meaning of this nephelo is called haziness or cloudiness. So all of you know turbidity is nothing but a cloudiness parameter. So sample ले लो सियोदिया, अभी शुरू करो.
Okay, so this one is the turbidity meter, sir, already explained, and
No
we
need
have
to
this,
any explanation. So
this is
you close your voice just to start the experiment.
Okay.
First you start it. First you start it. Now you see this one. This solution is very much. Is it visible? Solution is visible or not?
from top over solution.
Solution is visible or not?
Yes,
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 sir.
Yes, sir. Visible, sir.
Thank you. Thank you so much. So this one is the synthetic wastewater. We already prepared before this class. Okay. So during this measurement of the turbidity for wastewater, first we have to start this sample because uniform mixing is required. Turbidity is nothing but a haziness. As haziness, or rather called, that is nothing but a particulate impurities. Some particle already present in your solution. Okay. So we have to measure the particulate impurity in our wastewater in the form of turbidity. So please start this experiment. So this one is called the cuvette. First we have to take some sample inside the cuvette. Take it. इतना टाइम मेरा पास नहीं है सीओ दिया. Okay, everyone please see this one and listen my voice. Though my voice decibel is very high, I don't know. Okay. So this is actually, we are using some visible light for measuring this turbidity. That's why this is the question of outermost size of this cuvette. This glass bottle, another jargon people are using, that is nothing but a cuvette. So this instrument is already calibrated. So most of the instrument we are going to show, they are already calibrated, rather called pre-calibrated. Because if we want to show this calibration process, it will take another 15 to 20 minutes. Okay, so this instrument is already calibrated. So this cuvette, rather called some sample turbid solution inside the incubator, it should be entered inside the instrument. दिखाइए कहाँ enter करना पड़ेगा? Just you see the hole. Okay, and in the cuvette, वो वाला show कीजिए, down arrow show कीजिए. So we have to maintain this down arrow with this mark, and it should be inserted inside the inside the instrument. घुसा दो instrument अंदर घुसा दो. Then this is called light shield. It should be closed. It should be closed. And range कहाँ किया? Range auto range किया?
Yes, sir. It is auto range.
Auto range. Now, if we press here, you see calibration range. Okay, calibration range. Okay, then we have to press the read. We have to press the read. Read को press करो. Now instrument is try to measure the turbidity of our turbid solution and with the calibration one. Now you see what is the value is showing. Tell me. Tell me.
47.4.
Is it acceptable?
47.4.
If we say this water is drinking water, in terms of drinking water, कितना value आना चाहिए drinking water को?
Less than 1.
1. So is this a drinking water or wastewater? You have to say.
Wastewater.
100% correct. This one is the wastewater, and you can write in your notebook. Turbidity it is showing is 47.4 NTU. I think NTU is also clear. So this water is not our machine is saying this water is not a drinking water. You can't consume. If your only concern is the turbidity, even also you can't consume it, because as per drinking water standard, it should not be more than 1 NTU. Any question from your side? Otherwise, we have to shift for next experiment because time is very short.
बाबांचं टर्बिडिटी किती आधी सांगा म्हणून सांगा. अटेंडन्स पण घेतली बाबांनी.
Okay. Now we have to show the next experiment. So number 1 experiment is now over. Then you go for Siodia. Then you go for conductivity and TDS. Conductivity and TDS. So please listen my voice once again. I'm requesting not any order like this. Okay. I'm requesting all of you. Here conductivity, if I say, some people are asking you, what do you mean by conductivity? Because conductivity, some anionic and cationic impurities is more. If your sample is loaded by some anion and cation in your water, we feel that ionic impurities are more. I think it is clear. These ionic impurities we are measuring in our laboratory in terms of one very basic parameter that is called conductivity. And another conductivity related parameter is called TDS. TDS means total dissolved solid. Now come to the point. Quickly we have to pick up our knowledge. So conductivity is more means ionic impurities is more. But unfortunately, there is no standard for conductivity and TDS in our wastewater. But we have to compare with our drinking water. As per our drinking water standard, general drinking water standard, IS 10500-2012. You can write in your notebook also. IS 10500-2012. This is the latest standard for our common drinking water. Okay. So this drinking water IS means actually it is developed by BIS, Bureau of Indian Standard. They are recommending the TDS value of our drinking water should not be 500 milligram per liter. Now we have to see the conductivity as well as TDS value. Before starting the practical, don't forget it. Unit of the conductivity is called nowadays, that is the latest unit people are using, that is called capital S by cm. Cm per centimeter, capital S means Siemens per centimeter. You can search in your Google unit of your conductivity. So some people is saying not visible. Don't follow my picture. Please follow the Mr. PD Siodia's camera. Siodia, say something once again. Siodia.
Mr. Respected participant.
You say something. You are going to start one very important practical. So I am requesting those who are writing not visible. Please don't follow my camera. Listen my voice from my camera. And please follow Mr. PD Siodia's camera. Say something so once again.
Namaskar, माननीय participant.
Or say something, Mananiya participant. Why? Again dot.
Myself is PD Siodia.
Not the PD Siodia. You are going to start with experiment.
Okay, so for experiment, we are going to conduct this experiment, and experiment name is TDS, total dissolved solid.
अच्छा, अभी दिखाओ, अभी मत और कुछ मत बोलो.
Okay, sir.
Okay? So we are going to start for measuring the conductivity. So don't forget it. Conductivity unit is Siemens per centimeter. And irrespective of environmental laboratory, this conductivity practical is very, very important to judge the quality. Again, you are writing, Are Professor Mathun Kumar, please follow Mr. PD Siodia's camera. Otherwise, just you leave and again you enter. You leave and enter. I have done this one, pin I have done. So I am requesting all other participants, is it visible? Please say something from your side.
Yes, sir. It's
Clearly
visible,
Some
sir.
people, they are not believing.
Yes,
they are not believing.
Yes, visible. Clearly visible, sir.
Okay. Okay, now we have to start the conductivity practical. Suppose we have to judge this quality of our distilled water. At that time, this is the key point, key parameter, that is called conductivity. Forget about that, but don't forget it. Within second, you have to pick up your knowledge. Okay, I know you know this one. Again, I repeat this one. Okay, so unit of the conductivity is Siemens per centimeter. But whenever conductivity is very low, we are saying at that time conductivity value should be microsiemens per centimeter. Rather call, at a glance we may say that is mu, then capital S per cm. And if it is higher conductivity, then again another m we are adding, that is called small m, capital S per centimeter. That is called microsiemens per centimeter. But this instrument is showing mu s per centimeter. That is microsiemens per centimeter. And instrument also showing the temperature. Then again you are thinking, why temperature? Because conductivity is a temperature dependent parameter. So some of the parameters are depend on the temperature. One is conductivity, another one is the TDS, another one is the pH. So without wasting time, now please see in your naked eyes. Today we are going to use another pura instrument dekao, pura instrument dekao. We are going to use another giant company in our environment, that is called WTW. WTW, thoda bada karke dekhao. So this is US based company, another like hack. Don't forget it after this program, because sometimes you are all teacher. You have to prepare the equipment list. Okay, at that time, these are popular company in our field. One you already seen, that is hack. Second one is the WTW. Okay, so WTW also US based company, and here model number it is showing CON 720. CON 720. Okay, now we have to start our practical. Like turbidity practical, here also the same things, but instead of this cuvette, one probe dekhao, pehle probe dekhao, probe. This one is the conductivity or TDS probe. This probe should be inserted inside our water. Okay, तुम्हारा जो waste water वो वाला ले लो, waste water ले लो, waste water. थोड़ा जल्दी करो भाई, इतना टाइम हम मेरा पास नहीं है. Okay, so now after this one, our probe should be inserted inside the water. Okay, then instrument dekao, ek sath mein instrument dekao, keyboard. So as per this instrument num, this is not so much important. So first we have to press AR, press karo, then enter, So one thing is blinking, that is AR. As per this instrument, when AR is removed from the monitor, is whenever it is just now, the instrument is already stopped. There is no blinking. So that is the conductivity value of our wastewater. It is showing 19. Tell me, what is the value is showing?
1994 microsiemens per second.
Microsiemens per centimeter. Then don't forget it. After this experiment, whenever you are writing the result, you must mention the temperature. So you have to write at 27.8 degrees centigrade. I think it is clear. So if I ask you, is it drinkable water or drinking water? What is your answer? On behalf of you, I am giving the answer, because here the conductivity, there is no standard at all. So we can't say this water is drinkable or not. Some analogous parameter also there. These facilities inside the instrument also there. That parameter is called TDS. Now we have to measure the TDS just only changing the mode. Mode दिखाओ M. Change करो, mode change करो. So this one is the salinity. Next one is the TDS. But this is not the exact TDS. Same method we have to follow. Fresh air. अरे दिखाओ ना.
ये वाला दिखाओ ना इधर में.
अरे
ये वाला दिखाओ इधर में. ये इधर दिख रहा है ना. ये
fresh करो. Then enter. Now it is blinking, means your measuring value is comparing with the standard, because this is also a calibrated instrument. Now it is off. Now the value it is showing, tell me.
1298 mg per liter.
1298, but don't say milligram per liter at
Temperature of 27.8 degrees centigrade.
I think it is correctly visible. Okay, that's why you are saying the correct result. Very good. So quickly we have to leave from this experiment. Now, my only query is this: if we consider this water, SN Mondal just now offering before lunch, you have to consume this water. Are you ready to consume this water? Are you enjoy? Otherwise, it is meaningless practical.
No, sir. No, sir.
Why not no? Why not no?
It's beyond acceptable limit. Yeah.
TDS very high, sir, and already you told that we required less than 500 now.
Very good, very good, very good, very good. So our conclusion is now over. Now experiment number 3. So we have to go for pH. So Mr. Shiodia is showing our one of the dedicated instrument in our laboratory, this pH meter. थोड़ा मैन्युफैक्चर को दिखा दो, Shiodia. मैन्युफैक्चर को हाथ लगाओ. Here also the same manufacturer like TDS and conductivity meter. Here WTW. Here just to see the first screen, pH it is showing 6.99. Forget about that. This is 150 CS value. And below that one temperature already mentioned, because pH is a temperature dependent parameter. Without second, within 1 second, we have to pick up this knowledge. सियोदिया हमारा पास एक वो जो बफर सॉल्यूशन है, स्टैंडर्ड सॉल्यूशन है, वो वाला दिखाओ. उधर फोकस करो. See, we are showing one imported buffer, that is here pH is 10.01. Now we have to prove using this buffer solution pH is a temperature dependent parameter. नीचे वाला स्केल का फोकस करो. हाथ लगाओ सियोदिया, तुम हाथ लगाओ. हाँ, ऐसे रख दो, ऐसे रख दो, अभी रख दो. Just you see, standard pH value is 10.01. But whenever the temperature is 5, we are in Kashmir or Darjeeling, then the same pH value is 10.24. Okay, again 10. Whenever the temperature is 10, pH value is 10.18. But pH standard temperature when it is 25 degrees centigrade, that is 10.01. Within second, we may pick up pH is a temperature dependent parameter. Okay, now we have to start this pH practical. Start it. इसको निकाल दो यहाँ से. So please take some water. Okay. Just to see here, like conductivity meter, here also one probe. The probe is made of glass. So this probe should be inserted inside the instrument. कर दो. Now procedure. अभी keyboard दिखाओ. Here same procedure. We have to press first air press करो. Then enter. Back करो, back. Then you will start. Hold, yes. So just you see one bar is moving. Okay, it will take some time because your experimental result is comparing with the standard. Then this instrument shall give you the exact result when bar should be stopped, like air. Here bar is moving, just you see. Is it visible? Bar is moving. थोड़ा बड़ा करो. Is it visible? Bar is moving.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Bar is moving. So we have to wait for some time. So I may say the pH standard value as per schedule 6, that is effluent discharge standard. Now please listen my voice, that is also very much important. Effluent discharge parameter, that is very much important. What do you mean by now it is completed, Siodia?
Yes, sir.
Okay. Now please tell me the value.
7.91.
7.91. 91. Then
Temperature 27.9 degrees.
Yes, you are 100% correct. Whenever you say pH, sometimes we are facing lot of problem. If I ask you, madam or sir, pH, is there any unit? You may say yes, it is unitless. But something is there, you have to mention. That is at temperature. Numerical value, after that at temperature. That is very, very important. In case of conductivity, in case of TDS, in case of pH. Okay. Now, I may say another 1 minute on this topic. General standard for discharge for environmental pollutant, part A, that is effluent. If you search on this topic, you can get one PDF file. That is the discharge standard. Discharge standard means after generation of wastewater, rather called effluent, every industry should have ETP, means effluent treatment plant. So effluent, after treatment of effluent, industry is producing discharge. Okay, that is called treated wastewater. This treated wastewater generally we may discharge in the inland surface water, like river water, lake water, etc. We may mix this discharge water because this is treated water, treated wastewater. We may discharge our treated water either maybe public sewer or land for irrigation and marine coastal area. So these are this area categorized by our authority, that is CPCB, Central Pollution Control Board. Now I have to say the pH value, if after treatment, after effluent treatment, rather called discharge, rather called treated wastewater, whatever we are producing, obviously after treatment, after ETP plant, if we want to mix our discharge water in the inland surface water, the pH should be maintained 5.5 to 9.0. If it is public sewer, same value, 5.5 to 9.0. If it is land for irrigation, 5.5 to 9.0. If it is marine coastal zone, that is 5.5 to 9.0. So as per this discharge standard, this wastewater, if our concern only pH, there is no problem. If our concern only the pH, but our concern is not the only unique parameter, multi-parameter. Okay. So now we have to start another two important practical, that is practical number 4. That is the DO, means dissolved oxygen. उधर चला जाओ सियोदिया, तुम्हारा पानी लेकर के चला जाओ, इधर जो वेस्ट वाटर है वो लेकर के चला जाओ. Now we are showing another multi-parameter apparatus. इसको कंपनी दिखा दो, पहले कंपनी को दिखा दो, थोड़ा बड़ा करो, नीचे 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 कंपनी को दिखाओ, कंपनी. Tell me which company? Hack. Don't say hatch. Don't say hatch. Okay, this is hack. 100% correct. Okay, it is showing, the instrument is showing hack. So we have to change the ये जो है इसका एक्सेप्ट कर लो. अभी ये
है 1 बज गया सर, ठीक ही है सर.
हाँ, एक्सेप्ट कर लो.
है ओके सर.
वेट आने दो पहले आने दो. तुम्हारा लूज कनेक्शन हो रहा है वहां से. इधर नहीं है, पावर पॉइंट से. अभी ऑन करो. लिप करो, लिप. अभी कौन सा पैरामीटर दिखा रहा है?
सर DO.
So we are going to measure, this is multi-parameter apparatus. So you can measure the DO, we can measure pH, we can measure conductivity, we can measure TDS, we can measure, I may say, salinity, we can measure fluoride. But today we are going to measure two very important parameters. One is called DO, another one is called fluoride. Why DO is important? All of you know, DO is a part of the BOD. And relation in between, just I'm repeating the knowledge. I think you have this knowledge. Okay, all of you, you know this situation. Again, I am repeat. So I repeat these things. DO and BOD, there is some relation. Relation is not very friendly relation. That relation is called correlation, rather called inversely proportional. एक बढ़ जाएगा तो और अदर का वैल्यू कम हो जाएगा. मतलब if the BOD value is higher, means DO value is less. But in every water in our planet, BOD value should be less and DO value should be more, because DO is nothing but oxygen. And in Hindi, it is nothing but is called pran. Pran for what? Or life. Life for what? Life for flora and fauna. Flora and fauna. Because two kingdoms inside the water, one is called flora, another one is called fauna. Fauna means animal kingdom inside the water, and flora means actually vegetable material or plant being inside the water. They need oxygen. Matlab, if BOD is high, means DO is less, and that is not good for our life, like flora and fauna. If we consider the aquatic life, aqua means water. All of you know, aqua guard, you know this one. Okay, fine. So DO is a part of the BOD. So whatever BOD stand for don't say from today. Don't say from today. So better way for description of BOD, full form, don't say biological oxygen demand. As per US EPA, means United States Environmental Protection Agency, this name is called biochemical oxygen demand. But most of the books, it is already written there, biological oxygen demand. But suppose whenever you are doing some research, ultimately you have to publish some paper. In that paper, my request, not advice, my request, at that time, if you want to write the full form, please mention biochemical oxygen demand. Don't write biological oxygen demand. Forget about that. Now, BOD is very, very important because it is the question of level of, after measuring the BOD value, you can measure the DO level. Okay? In terms of DO level, BOD is very high. Matlab, within second, your conclusion DO is less. DO is less, and that is not good for our life. Life means basically for aquatic life. Now today we are going to measure the BOD in terms of DO. What is the meaning of this one? So within 1 minute we have to pick up. Suppose today is 27/10/2021 and the time is near about 1:08. Okay, 1:08. This is the time. And you already received one effluent, rather called wastewater, and you have to measure the BOD. So this instrument is sufficient along with one incubator. Incubator is very much required because you are going to measure BOD in terms of DO. What we have to start, first you take some sample, raw sample, you measure DO. After measuring the DO, just to write down in your notebook. Okay, then it should be incubate. Incubate means we are using one instrument that is called incubator, where we can fix the temperature. So that's why it is called incubator. Sometimes all of you know incubation is very much required for premature baby, but here also in this experiment, premature baby are our microorganism. So microorganism must be grow. Okay? Without this microorganism, your DO means dissolved oxygen present in your solution cannot react with biodegradable organic matter. Okay? That's why temperature sensitive experiment. So what we have to do in this experiment, first, just after receiving the sample, please measure the DO level. Same sample should be incubated at least 3 days. If it is 3 days, then temperature should be fixed 27 degrees centigrade. If it is 5 days temperature should be fixed with 20 degrees centigrade, because I already explained BOD at 27 degrees centigrade for 3 days value more or less equal to BOD at 20 degrees centigrade for 5 days. Okay, after 5 or 3 days, incubation period may be over. Then again you measure the DO level. That DO level will be higher or lower? That is my query. Say something, those who are present only.
No,
It will be less, sir.
Less, fine. Obviously, that DO level should be decreased. Why? Because some microorganism already there, DO also there. And this DO react with our biodegradable organic matter. Okay, DO should be consumed by our biodegradable organic matter in presence of our baby, that is premature baby. That's why temperature is very, very important, because growth of the microorganism depend on the temperature. So without wasting time, just you see the practical. And this is the ultra modern practical. Today we are showing here, we are using one probe ko dikhao. So this one is the latest technique. Here we are using light for measuring the dissolved oxygen. Can you imagine it? Okay, that's why this probe is called capital L BOD probe. Capital L for light. Okay, we are using for light. This technology is available in the market for measuring the DO level. So this instrument is sufficient, not only DO, for BOD also. One DO for BOD, we need another instrument, additional instrument we need, that is called incubator, that is called BOD incubator. Chalu kijiye experiment. Okay, just to see, this is our wastewater. And BOD bottle दिखाओ, BOD bottle, दोनों एक साथ में दिखाओ. Collect. So this one is the BOD bottle. Collect the sample. Very good. And we have to insert this LBOD probe. Water seal हुआ, थोड़ा डाल दो, थोड़ा डाल दो.
अच्छा डाल देता हूँ.
थोड़ा डाल दो. हाँ, अभी घुसाओ. Is it visible? Is it visible? Those who are present only.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
You have to enjoy. Otherwise, this type of class is very much monotonous. You have to enjoy with, obviously, with technology. So inside there, one starter को हाथ वहां से निकालो. तुम्हारा हाँ, one starter is there. Now we will start this one. Just you see, starter is now, because uniform mixing is required. Is very much for measuring this DO. फिर इंस्ट्रूमेंट दिखाओ, एक साथ में दोनों दिखाओ. इंस्ट्रूमेंट दिखाओ, लाइट ऑन करो, इंस्ट्रूमेंट का लाइट ऑन करो. हाँ, दिखाओ इंस्ट्रूमेंट दिखाओ. Now we have to press simply, because this is pre-calibrated instrument. Milligram per liter LBOD we are using. We have to simply press the reed. Reed को press करने, हाँ, we have to press करो. Okay, same thing is happening. Just you see, अरे पूरा ये करो, monitor को दिखाओ. So stabilizing the reading. Just you see. Bas. Now, tell me your DO level of this wastewater.
6.81 milligram per liter.
Okay, so this is very nice instrument. Okay, so within 10 to 22nd, you can measure the DO level. So for BOD, what we have to do? Again, this sample should be incubated inside the incubator. Okay. So my request to all of my participants, those who are present just now, you can come and join one contact mode program. Then you can use in your own hand this type of instrument. Then it should be very much clear. Okay. Now LBOD, LBOD probe you already used, DO you already measured, and DO level is ek bar dekhao CODR, DO level 6.81. 6.81 and temperature bolo, temperature ko dekhao 27.7 degrees centigrade. So whenever you write the DO, you have to mention the temperature, because all of you know DO is also a temperature dependent parameter. Same instrument we are going to use for measuring the fluoride ion concentration. That is another very important parameter. शुरू करो सियोदिया, फ्लोराइड को इसका यहां से निकल जाओ. Yes, now we are going to start the fluoride ion concentration. I may say only 1 minute on this topic, because fluoride is very, very important parameter for our drinking water. All of you know. Some fluoride is very much essential for the development of our enamel. That is the hard thing in our teeth. But the same fluoride, if it is more than the standard, it is very much detrimental for our health. Same fluoride, if it is more than the standard, again, the higher fluoride concentration again attack your teeth. Not only the teeth, as well as your skeletal system. Means your bone. Your bone may be bent. Your bone may be bent if the fluoride concentration is more than the standard. Okay. So what is happening? So we have to remember the fluoride ion concentration as per our drinking water standard, it should not be more than 1 milligram per liter. But some fluoride every day we have to take, because the lower concentration of fluoride, because less than 1 milligram per liter fluoride are helping to develop our strongest part of our teeth, that is called enamel. But if it is every day we are consuming some water whose fluoride ion concentration is more than the standard, that is drinking water standard is 1 milligram per liter, suppose the value may be 1.5, 1.6, again this extra fluoride again attack your teeth as well as skeletal system. So my discussion is over. Here we are going to use the latest techniques. Here the electrode name is called ISE. ISE. Matlab ion selective electrode. Here this ion selective electrode, I may say that is called fluoride ion selective electrode. Thoda dekha dijiye. Fluoride ISEF. ISEF means ion selective fluoride electrode. Bas theek hai. Ion selective fluoride electrode. So this is the latest technique for measuring the fluoride ion concentration in our water, either maybe wastewater or maybe any drinking water. But one thing we have to remember here, be cautious about it. Every container should be made of the polymer. Even also, this fluoride electrode is made of polymer. So no glassware you can't use for this experiment, because all of you know, if you apply your common sense, glass contains one of the ingredient of the glass is fluoride. So if you use the glass container, you can get the actual fluoride present in your wastewater. So please start Siodia practical. Here तुम्हारा सब glassware दिखा दो. This one is made of glass. The container is made of glass. And a small container दिखाओ. तुम्हारा reaction cell दिखाओ. This beaker also made of glass. Le lo, 25 ml sample is required. थोड़ा जल्दी करो सियोदिया, थोड़ा जल्दी करो. So number 6, fluoride. Yes, 25 ml.
Yes, sir.
Please take it in a container. Then ion selective fluoride electrode should be inserted inside this one. Before that one, we are measuring fluoride in acidic condition. That's why, as per these techniques, we have to add one buffer pillow. बाद में करो, वो छोड़ दो. So this one is buffer pillow, where we are trying to maintain our solution pH 4 to 6. So this part is over, because we are going to use this ion sealant. It should be inserted inside one magnetic stirrer, because uniform mixing is required during this experiment. Okay, so this is nothing but only the mixing part. This is the 7 number practical, experiment number 7. Times with our hand another 10 minutes for this class. We shall try to finish another 1 or 2 experiment if time permit. Now the fluoride ion selective electrode should be inserted inside the solution without disturbing the magnetic stirrer. थोड़ा दिखाओ, नीचे से दिखाओ, नीचे से. It should be already inserted. Okay, now show the instrument main part को show करो. Just you see here, this one, the ion selective electrode fluoride 121 is the model name, fluoride ion selective electrode. Then simply we have to press read को press करो. Yes. Now one bar is moving after stabilization. इसका ऐसे रख दो. Siodhya, stabilizing होने दो. After that, after stabilization, you can show the reading. Okay, before that one, वो हमारा jet tester का पास चला जाओ.
Yes, sir.
Jet tester का पास. So we'll see the reading after some time. Nothing else. After stabilization, obviously, before leaving, I shall show you the result. So, okay, so just you shift your place here to jet testing. In NITTR Kolkata, we have another laboratory, that is water and wastewater engineering laboratory. Okay. Now, one thing should be clear before leaving of this experiment. So this one is the Mr. Siodia has tried to show the jar testing apparatus. Before that one, all of you know, Dr. Ashim Kumar Bhattacharya already explained the one thing that is settleable solid. And another one is the unsettleable solid. Another one is called a dissolved solid. So within 1 minute, we have to pick up. What do you mean by settleable solid? In the settleable solid, the particle size is very high. We may say mg is very high. In our laboratory, we are measuring the settleable solid. इमहब कौन का पास देखा दो, इमहब कौन का पास ले जाओ. अभी ये माप दिखाओ. This one is called the one some conical instrument. Its name is called IMHOP cone. You can write in your notebook. IMHOP, HOFF, CONIM, not IN. IMHOP cone, CONE. This instrument actually we are using for measuring the level of settleable solid. But unit of the settleable solid also unique. We have to remember. The unit of settleable solid is milliliter per liter. That is very interesting. And this is the part of a one design parameter for wastewater engineering plant design parameter that is called SVI. Full form of the SVI is called sludge volume index. Sludge volume index. And in this IMHOP cone is giving some idea whenever settleable solid are going to settle, how much space they will occupy. And that is the very important part of our design engineer. Now simply we shall show you, once again I repeat, unit of the settleable solid is milliliter per liter. And this is very, very important experiment for wastewater engineering laboratory. Okay, here we shall show you how to measure the settleable solid. For this one, we need 1 liter of water. That water must contain some settleable solid. Okay, तुम्हारे पास वाटर है तो थोड़ा एजिटेट कर लो, वाटर को मिक्सिंग कर लो, अच्छा करके मिक्स कर लो. Okay, so this pani should be transferred from this beaker to the IMHOP cone. Not more than 1 liter. Direct डाल दो, without any hesitation. But not more than then we will show you another very interesting thing. डाल दो, तुरंत डाल दो. Yes. Wait. उसका वो जो ये है ना, सियोदिया, स्केल को बोलो, स्केल को.
This is 1 liter.
Just you see, this is 1 liter. Okay. And here below वाला देखो, below एकदम below से. So settleable solid only settle down the bottom. Just you see. What is called settleable solid? अरे अच्छा करके पकड़ो. Don't shake it. Don't shake it. So now it is called the settleable solid. Settleable solid is rapidly settling. And here, वो scale दिखाओ, scale. Bottom वाला जो scale है, bottom का जो scale है, इसका दिखाओ. हाँ. So here unit, just you see 1, 2 like this. And here, if it is 2, the solid height, now it is showing very near to 0.5. Then 1, then 2. Here, unit of this 2 means milliliter per liter. So this is very important points for the wastewater engineer. Now you see so for this experiment, you have to wait for 30 minutes. After 30 minutes, you must measure the height of this solid. And if it is 2, suppose after 30 minutes, if it is 2, थोड़ा prominent करो, 2, 1 इसको, back side में हाथ लगाओ, थोड़ा बड़ा करो, बड़ा करो, 2 को prominent करो, 2, अच्छा नहीं आ रहा, अरे इतना पास में मत लाओ. Okay, here just you see 2, 6, etc. So if the height is 2, so our settleable solid means milligram per liter. No, not at all. Here unit of the settleable solid is milliliter per liter. Milliliter per liter. Don't forget it. So this is the part of the SVI. SVI is called sludge volume index. Now quickly I shall discuss on the jar testing apparatus. So some solid after 30 minutes may be settled down. Please listen my voice. But most of the solid present in our water, they can't settle. That is called actually the colloidal particle or unsettleable solid. So if I ask you how to remove this unsettleable solid, rather called colloidal particle, then I think you are thinking, yes, Dr. S.N. Mondal, we are some capability to settle our colloid particle. Pans, what is the pans or technology? Anyway, if we increase the colloidal particle solid to settleable solid, then it is easily settled down from your solution. If anyway, just you listen my voice, that is the very interesting parts of this program. If anyway, colloidal particle or unsettleable particle size is lower than settleable solid, that's why they are floating. They are not settled. What we have to do? Anyway, the punch is like this. Anyway, if we increase the size of the colloidal particle from colloidal particle to settleable particle, so it is easily settled down. It may deposited, it may sedimented, it may separate from your solution. For this one, we have to do one pilot scale study. For this pilot scale study, तुम्हारा jar tester दिखाओ एक बार, jar tester दिखाओ. This jar testing apparatus is very, very important. So actually, for increasing the colloidal particle to settleable particle, we need some external chemical. The external chemical may be alum. What is happening? Whenever we are adding alum inside our unsettleable solid, rather colloidal particle, then alum is highly electropositive cation, all of you know. But most of the colloidal particles present in our solution, they are negative in nature. Mostly 99%, sometimes 95%, they are negative in nature, our colloidal particle. Okay, they are negative in nature. So what is happening? Whenever you are adding some alum inside the solution, alum produce aluminium 3+. And your most of the colloidal particle, they are negative in nature. Then in between alum and in our unsettleable particle, rather called colloidal particle, some interactive force. Some people say, those who are sitting over here from chemistry department, that attractive force is called the van der Waals attractive force. Forget about that. Some attractive force shall develop. Ultimately, the particle size will increases. Then, whenever it is increases, they may separate from your solution. But question is this: what is the optimum amount of alum is required to separate our colloidal particle? And we must achieve our standard. That study is called pilot scale study, rather called dose optimization study. I can assure you, you can set this experiment in your laboratory. And if you are dealing with diploma laboratory, diploma student, no problem. Degree student, no problem. Master degree student, no problem. Even also PhD student, no problem at all. Okay, so this is very, very important instrument for water and wastewater engineering. So we are very near to 135, near, very near. Okay, so just now we have to see the fluoride ion concentration. एक बार दिखा दीजिए सियोदिया, फ्लोराइड कितना आया, फ्लोराइड कितना आया? So लाइट को जला दो, दिखाओ वैल्यू दिखाओ. See the stable value of fluoride of our wastewater. It is 0.0860. I may say in case of fluoride, our discharge standard after ETP, I'm saying if it is inland surface water to 15. So 15 is the maximum value in case of your treated wastewater. But here it is showing 0.08 milligram per liter. And in our drinking water standard is not more than 1 milligram per liter. So if our concern is only the fluoride, is it acceptable or not? That is my last query.
Yes, sir. It acceptable.
Less than 1.
Okay. So now I have to conclude. Your answer is so much correct. So in this program, we already shown some of the instrument, not all the instrument. Okay. So my request to all of my professor after pandemic, please join one contact mode program if it is possible. This is my request. Then only you can use each of the dedicated instrument in our laboratory. We have spectrophotometer. We have atomic absorption spectrophotometer. We have residual and free chlorine measurement separate instrument. We have our air pollution monitoring laboratory, so many things. Okay, this is something advertisement, not more than this. Technical advertisement, not like say buy one, get one free, not like this. Okay, so with this, thank you so much for your patience and for obviously your concentration, those who are present. Okay, I think you enjoyed this short laboratory demonstration. In future, obviously, whenever we are conducting some online training program, not like ATOL, AICT program, this is span is only 1 week. It is not possible to show even also 10 or 12 number of practical because time is the constraint. So basically we are conducting 1 week program, 2 weeks program, etc. So you can join even also in online program. Okay. With this, thank you very much. If you have any query, just to write in your notebook, we shall discuss later. Don't worry. Thank you so much.
Thank you, sir.
Thank you so much.
Thank you, sir. Thank you.
Thank you, sir.
Thank you so much.
Thank you, sir.
Yes, still you are present. Okay. Thank you so much.
Thank you so much, sir.
Yes, sir. Thank you.
Thank you, sir.
Thank you. Thank you. Thank you. So we'll meet at 2:30.